Function. The math describing those possibilities was just a tool for prediction, not a real thing. Others weren't so sure because the math worked too well. It wasn't just useful, it was precise. It predicted outcomes with accuracy no other theory ever matched. So maybe the wave function wasn't just a trick, maybe it really was the thing. In which case, the universe at its core isn't made of particles or matter, but a probability. That's not speculation, that's the backbone of modern quantum theory. When you calculate what an electron will do, you don't get a position, you get a wave function, a spread of outcomes. You get a cloud of potential answers, and it's only when you make a measurement that one of those outcomes becomes real. But what does that mean? That there wasn't an electron until you looked, that it had no position till you asked the question. Some physicists try to avoid this by introducing hidden variables, invisible properties that the particle really had, but we just couldn't see. The problem? Those theories got destroyed by actual experiments. In the 1960s, physicist John Bell came up with a test, a way to check whether reality was hiding some deeper layer underneath quantum mechanics. Those tests were finally run in labs across the world. They all pointed to the same uncomfortable conclusion: the universe doesn't work the way we think. There are no hidden variables. There's no deeper layer where particles are just waiting to be discovered. What we see is all there is. It only shows up when we look. This is known as Bell's theorem, and its implications are brutal. It tells us that either information can travel faster than light, which breaks relativity, or that reality isn't real unless it's observed. You have to choose, and neither option feels right. Now, bring in another experiment, the delayed choice quantum eraser, first proposed by John Wheeler in the 1970s and experimentally realized in the 1990s. This one takes things even further. In this setup, you fire a particle at a double slit screen, but wait to decide whether or not to measure it after it's already gone through the slits. And somehow, depending on whether you choose to look or not, the particle behaves retroactively, as if your choice in the present changed its behavior in the past. It's not a metaphor, that's what the data shows. The future influences the past. The act of measurement doesn't just reveal the outcome, it seems to determine what the outcome was all along. This throws everything off balance because it means that time isn't what we thought it was, that cause and effect are blurry, that the arrow of time, past the future, might not be fundamental at all. And this is where things begin to collapse, not just particles, but the very idea of the universe being there in any classical sense. Because when you zoom in far enough, there's no thing to find, no little nugget of matter. Shit.